Hello everyone, welcome to this quick overview and tutorial of the InStep Studio application and how to use it for converting an STL to a step file. Specifically, we're going to take a look at converting a PCB assembly, creating DesignSpark, and convert the main PCB into a CAD file for use in a mechanical definition. What we're going to go ahead and do, if it hasn't been done already, is turn on the messages box. So we click here and turn on messages, and you can see that that brings up the message field on the side where we can get some information during the process. I'm going to go ahead and import a sample file. This is a PCB.stl type file. The first thing that will be asked if we want to split it into separate bodies. Generally this is a good idea. Here I'm actually going to go ahead and click no. I'm going to leave it as a single body just so we get an idea of what's actually going on. If I turn on the edges with Alt-E, we can see that there's a number of components, just simple blocks that sort of all placed in the same place, and it just makes up one big lump of items. So we're going to go ahead to the Bodies tab, and we're going to pick the split option, and that this part would have been done automatically if we said yes, but we're just going to leave the default. We don't want to use an angle for splitting the non-manifold edges. It's generally a good idea to leave that on, but there's no effect here. So we're going to go ahead and take a preview, and we can now see with different colors how the different bodies will be separated, and that all looks fine. So I'm going to click apply to make that change permanent. So at this point for this tutorial we're only interested in the main PCB, so we want to get rid of all the other bodies, so we could individually click on them. And by the way, this is a click or a control click to unselect, so click to select them all or control click to unselect. We can then go ahead and right click and do delete body, but in this case there's also a faster way. We can select on the one we do want to keep, right click, and then delete all others. So we're now left with a PCB, and we can clearly see the faceted style that the STL and OBJ as well for that matter, the file formats, they just represent data in this way, and it's just a bunch of triangles. We can go ahead and export this to STP and use it this way, but it's very inefficient. So in InStep Studio we have the option of finding features within that data. So we clicked on the Features tab, we click on the Preview tab, and after a couple of seconds it'll tell us what features it can detect. And let's go ahead and turn off the edge display with Alt and E, and now we can kind of get a good idea of what's going on here. We can see cylinders, we've got 71. We can turn them on and off to make things easier. We don't have any cones, so cone would mean it's not just a straight cylinder but it ends in a point. A truncated cone would be the same but doesn't end in a point, ends in a flat surface. Don't have any of those either, but we've got 8 quads along the perimeter, and we've got 2 polys, so the 2 top sides. What's good is we don't have any trees or triangles, meaning all the original surfaces have been combined into one of these types. Now what's interesting is the quads here, we can't quite tell, where one ends and where the next one starts, so we can click on the random colors, and what that'll do is it'll just assign a random color to all of the features. That allows us to distinguish what features where. And if you have a case like this where you're like, well, this is green, this is also like a darker green and can't quite tell, just cycle through this and it'll assign a new color each time, a random color so to speak. Alright, so this all looks fine. Let's go ahead and make this permanent. We click the apply button, and in this case it's very quick, and it'll just convert it all into the respective features. And you can kind of see that the original surface definition is still there for some cases. In other cases it's been completely converted to a new one. If we don't like that, we can go back to the Bodies tab, select it and change the color, and end up with a PCB style green, whatever is appropriate. Okay, so that's pretty much all we wanted with that. So let's go ahead and export it. Note there's also STL and OBJ formats, and there will be additional items here in future versions probably. But for now, we're just going to go ahead and export as a step, because if we export as an STL and OBJ again, we're going to lose the feature-based definition, just because those formats can't really use those style items. OBJ will try and keep these as quads, but STL will just go back to triangles. So we go ahead and click export to step. We're going to reuse this one here. Yeah, we're going to overwrite, and you see basically 0.1 megabytes in 0.6 seconds. So it's very efficient, very fast, and it's very compact too, which is exactly what we're looking for. Now, because this was imported from DesignSpark PCB, might as well take a look at what this looks like in DesignSpark Mechanical. It's a free application. It's actually quite a good application for this kind of stuff. Turn on the check geometry. Want to make sure that all the data is converted properly, and we can see no geometry problems were found. So that's good news. Sometimes you might encounter issues with tolerances and things like that, and there's not really an easy way to resolve that if the CAD application can't figure that out. I'm also going to load this into Alibre, which is the CAD application I use here most, just because I can show some additional features there. Go ahead, import that. I'll leave the healing and everything pretty much turned on at the highest settings, so I'm going to be quite harsh on it here. Leaving the healing option is generally a good idea, even though it can take just a little bit longer. After a few seconds, it will complete and it'll show file import without errors. That's obviously good. We can kind of go through. There's nothing failed, otherwise it would have told us. So that's pretty much all we wanted. Now we have a fully converted CAD file that we can use for mechanical design and so on. I do want to point out one thing. So if we switch to the sketching options here, and let's pick one of these edges, or actually let's just convert the whole thing. So once this completes, we can actually see that all the features, if I look at this, it tells me this is actually made up of an arc. We can also do an advanced selection. So if we advanced select here, it'll actually tell us this is an arc. So this isn't a spline just made up of a bunch of points or anything like that. This is a true arc defined by center point and the radius. So that's a very useful conversion of the features for this purpose. And that's that.